The sun. And guess what's going on with it? Well, you don't have to guess. We take the guesswork out of it. What's going on with it is another major solar uptick. Multiple new sunspot groups have formed. This is the past. Well, it's yesterday plus today from the Solar Dynamics Observatory. Huge number of plasma filaments on the Earth-facing portion of the solar disk as well. It is exciting times for space weather. We'll talk about it and lots more here at the Smash News Network, least busted name of news. And by the way, thanks for tuning in. Let's zoom out to the full disk view. Again, that's 304 angstroms from SDO, yesterday plus today, September 30th, the full day, and October 1st to date. So we'll have no less than 3 new likely named sunspot groups in the next 24 hours, so we'll see another uptick in the sunspot number. Again, exciting stuff going on. Here's a great composite. Here we've added 211 and 171 angstroms to the 304. So you can see some coronal holes there. You might see some new sunspots. Don't worry, we'll tell you all about all of the specific features here at the Smash News Network, least busted name in news. The world's most comprehensive daily space weather content and most detailed solar imagery you'll find in the known universe. If you're new to the channel, do yourself a favor and press the subscribe button. Press the like button. Whether you're new to the channel or not, leave a comment, press share, etc. Visit our links. You'll find links below the video in the description. So check those out. All kinds of other ways to get involved on social media. Check out the sweet imagery we've got. I mean, there ain't no competition to the Smash News Network, least busted name in news' coverage of the daily space weather. So those are just some facts, some very controversial facts. Pardon the controversy, folks. Another major solar uptick in progress. So again, visit those links below the video in the description. One of those is the link to the Smash Team. If you want to support the channel, do it via the Smash Team. Become a bronze, silver, or gold level Smash Team member. Get email alerts sent directly to your email inbox so you never miss a video like this one. The bronze level costs you $0 a month, and it even gives you additional content that you will not get just on YouTube. Links below the video to the Smash Team, the homepage, and more, like our Amazon shop. Have you switched to organic coffee yet? I'm drinking organic coffee right now. It's the actual Cameron's product that we're showing right now. So, oh, so good. Anyway, if you haven't switched to organic coffee yet, maybe you ought to. I'm not saying it has pesticides in it, but it might have pesticides in it. So, perhaps consider switching to Cameron's organic Scandinavian blend. Pick it up right from our Amazon shop. Have it delivered straight to your door. It's super convenient. It might look expensive there, $35.87. That is for a 4-pound pack. So that is a lot of coffee for not a lot of cash. So the Cameron's Organic Scandinavian blend, highly recommend it. Again, because if you haven't switched to organic coffee, let me just share a personal story. When we switched to organic coffee, Smash staff and I stopped getting the jitters from drinking coffee. So, cheers. I'm super sensitive to chemicals, so perhaps you are as well. Cameron's Scandinavian blend in a bulk pack to save some dough on your organic coffee. Another link you can find below the video is to our Hemp Lucid shop. So if you're picking up CBDs, immune stacks, stress stacks, mushroom gummies, and more, pick them up via our Hemp Lucid shop. Save some cash on stress, immune, and what's the other one? Sleep stacks. Yeah, save $15 on all 3 of those, or save even more by getting the full stack package. So that's another way to support the channel. Help keep these videos existent by visiting our paid affiliate /sponsor links. We endeavor to create a sustainable operation That's why we have the links. So, I mean, citing facts is very controversial, folks. So, we apologize for all the controversy that we create with facts. And speaking of controversy, let's create some here by talking about the galactic current sheet. So this non-existent structure is some nonsense that a certain YouTube channel states that is a thing, although there's no evidence that it is a thing. The local interstellar environment is filamentary and is nothing like the solar system in any way. The galactic core is about 26,000 light years from our solar system and extremely unlikely to be interacting with it in any meaningful way. There's a lot of dust in between this solar system and the galactic core. So this idiotic recycled idea from some electric universe nonsense or something like that, it's just a non-existent structure that's blamed for anything. Is there mold growing in your favorite houseplant? Well, it's because of the galactic current sheet. Is Jupiter's red spot looking like it's shrinking? It's because of the galactic current sheet. Are Saturn's rings dissipating? Galactic current sheet. Is the sun shutting down? Galactic current sheet. Is the sun increasing in its activity? Galactic current sheet. Are you having a bad day? Galactic current sheet. Have you joined a cult, and are you believing a bunch of nonsense? It's all because of the galactic current sheet. So that's today's featured product from the Red Bubble Shop, which you can link below the video as well. And let's talk about all of this nonsense associated with this ridiculous fictional thing, the galactic current sheet. Also solar micronova. Micronova is not a thing either. All stars are big. And the polar excursion, also not a thing from a geologic perspective. What's currently going on with Earth's magnetic pole shift is not even a blip on the radar. So let's talk about all this spooky energy from space that certain YouTube channels are claiming is increasing. Well, it's not increasing in any way. And what I'm showing you here is this is actually kind of an old image, but what it's showing you is the relationship, the inverse proportional relationship between the sunspot number, which is the red line up top, and the cosmic ray flux counts, which is the blue line at the bottom. You may notice that when we have a high amount of sunspots, we have a low amount of cosmic ray flux. And when we have a high amount of cosmic ray flux, we have a low amount of sunspots. Solar minima are associated with cosmic ray maxima and vice versa. So, why am I bringing this up? Because energy from space isn't increasing at all. It was at its highest levels in late 2009, as you can see right there on the graph. Clearly shown right there. There it is. Because the deepest solar minimum that we've had of the modern age was the transition between solar cycle 23 and solar cycle 24. At that time, the thermosphere was the coldest ever measured. Cosmic ray flux was the highest ever measured. Sunspot number was extremely low along with the radio flux. It was a very deep solar minimum. In fact, it had some people thinking that we're going into a grand solar minimum, which would require at least 2 weak solar cycles in a row. However, we don't see that. We don't see 2 weak solar cycles in a row, so if you're banking on a grand solar minimum, you're doing some bad banking, because it's going to be at least another, 30 years until we could have a grand solar minimum, because again, you have to have 2 weak solar cycles in a row, and solar cycle 25 is not a weak solar cycle. Case in point, that graph right there. So we shared this on Instagram and on Facebook and on Twitter. Notice how cosmic ray flux on all of the relevant monitors is at the lowest levels since 2004. You see that? 2004. Energy is not increasing from space. And by the way, you shouldn't call cosmic ray flux, quote, energy from space. That is complete layman's terminology, and it's basically meaningless. Cosmic ray flux, lowest level since 2004. There are the facts. And let's move on to get to some more space weather stuff, because I don't want to talk about this nonsense anymore. It's barely even worth commenting on. However, hundreds of thousands of people are convinced of this, despite clearly not understanding any of the physics or data. So anyway, here's yesterday plus today from SDO IntensityGram, and check this out. If we bring this forward, there's a new sunspot. There's another new sunspot, and guess what's up here? Yeah, another new sunspot. Here's the colorized magnetogram for that same period, September 30th and October 1st to date. So 3 new sunspot groups about to get named later in the day today. It's what you call another solar uptick. We'll talk more about the fact that the sun is continuing to tick up as we approach solar maximum, which we are clearly not at yet. And let's continue on and briefly discuss volcanoes and earthquakes. So these are the volcanoes that are erupting. Subanose-jima is producing a 7,000-foot ash plume over the Ryukyu Islands as it explodes. Mount Mayon, Luzon Island, Philippines, is producing an unknown volcanic ash plume. Please do not pole vault the caldera. Luatolo is exploding. Flight level 070 over the Lesser Sunda Islands. Semeru on East Java, Indonesia, producing a 17,000-foot ash plume. That's another uptick at Semeru, I believe. I think one of our viewers might have actually forecasted that one, so cheers to you. Dakono is exploding as well, flight level 070 over Halmahera, Indonesia. It's a 7,000-foot ash plume. 19,500-foot ash plume over central Mexico as we move to North American volcanic activity. There's Popocatépetl exploding. It's a flight level 195. Fuego in Guatemala not detected. It could be erupting. It could be cloudy. Who knows? Nevado del Ruiz, also volcanic ash not seen in satellite imagery. Possible volcanic ash continuing from Sangay in Ecuador and Revenador. And Sabancaya exploding in Peru, producing a flight level 240. It's a 24,000-foot plume of volcanic ash. Next, earthquakes. And while seismic activity is kind of low, there was a 4.7 at California. There you go, at Ferndale. 15:26 Universal Time yesterday saw a 4.7 at Ferndale. And let's just take a brief look at that to show the location. Just south of Eureka, which is actually, that area right there has been the most seismically active location on the U.S. West Coast for some time. We're going to cite quakes of a 5 or greater magnitude, and there haven't been many over the past 24 hours. So most of the activity here is once again in the southwest Pacific, as it's been for the last solid week, such as this. Well, this is actually on the coast of the Indian Ocean, but that's a 5.3 at Indonesia there. That was at 4 o'clock this morning on October 1st. And what else do we have? What else do we have? Only one 5 magnitude earthquake over the past 24 hours. And let's head back to space. A frontier. These are the voyages of the SDO. That's the 171 angstroms wavelength, the house favorite. And the most likely place to see large flares remains in the northeastern limb at the moment. It is where the most flaring has come from for the past 24 hours for sure. And let's talk some more space weather stats. The 10.7 centimeter radial flux has come up once again. It is now at 159 solar flux units. And for our regular viewers, you're well aware that the 10.7 centimeter radial flux is proportional to sunspot number. So there's the 1-year graph of the radial flux depicted by the black line. The red line is the sunspot number. When you see a high radial flux, you see a high sunspot number, and so on. Anyway, NOAA is forecasting some geomagnetic unrest both tomorrow and on Tuesday. Not sure why, though, because their Enlil spiral doesn't show anything. So, I mean, I would suspect it's because of a coronal hole high-speed stream. So we could see geomagnetic unrest starting, according to NOAA, early in the day tomorrow through about midday on Tuesday. Again, I suspect it's because of a coronal hole high-speed stream, but here's their Enlil spiral, and it's not really showing that. So, I don't know. That's what NOAA's forecasting. I don't have a problem with it because there is a coronal hole, and indeed, it could be producing some geomagnetic activity. Let's hope. Speaking of geomagnetic activity, not a lot going on Earth. Here are the past 4 hours of Earth's magnetic moment from space. Our Geospace Magnetosphere movie. It depicts magnetohydrodynamic pressure, the units of which would be nanopascals. So you'll see most of the pressure here on the magnetotail side, the dark side of the planet. That is because of weak solar wind inputs as the system tries to reach static equilibrium. Here's Earth's magnetic moment from the ground. This depicts magnetic flux density, the units of which are nanotesla. Again, it is quite geomagnetically calm. We've got a quite unremarkable solar wind for the past 24 hours, which we'll show you here momentarily. And we'll let that play through since it's refreshed. In order to get these videos onto your screen as quickly as possible, to make the videos as timely as possible, we do not edit them. So that's why it seems a lot like a live format. So there you go. There are the past 4 hours of Earth's magnetic moment from ground level. And the KP index, which is an average of global geomagnetism, is currently at 2. KP2 is the geomagnetically calm condition on planet Earth. Meanwhile, at Lagrangian point 1, as measured by the Discover spacecraft, depicted by this blue bar down here, solar wind speed is nominal at 424 kilometers a second and quite diffuse at only 3.16 protons per cubic centimeter. So if we do see a coronal hole high-speed stream show up, you can expect to see an increase in the solar wind density, followed by a decrease in the solar wind density and an increase in the solar wind speed. That's just the way coronal hole high-speed streams work. GOES magnetometers here, fairly smooth for the past 3 days. And you can expect to see some gyrations in those as well if we see gyrations in the incoming solar wind. Next, our top view ecliptic plane field plot. And just as we forecasted yesterday, the sector boundary crossing is very close. So Earth will be snapping into a South Pole current sheet later today. Keep in mind this data was already 1 hour and 9 minutes old when we created the video. So sometime before... let's see. Sometime before midnight universal time, we can expect Earth to be in a South Pole current sheet. Get rid of that arrow. This is the South Pole current sheet. And here's the North Pole current sheet with which Earth is about to leave. So here's our line of sight field plot. And that just sort of gives us an overall picture of solar magnetism. So it's showing coronal magnetism there in green and red. Those are the polar fields. And then it's showing the photosphere's magnetism in grayscale. That's the Gong 2 grayscale imagery there, depicting the magnetism of the surface of the sun, known as the photosphere. And then, of course, you've got the B field there, which is the sort of the net field depicted in blue. That brings us to coronal holes. And that's what's going on with coronal holes. We've got some South Pole oriented ones here rotating in from the east. No real surprises there. And let's take a look at those from SDO. So here's the SDO 211 angstroms wavelength. This coronal hole right here is the one that we're expecting a high-speed stream from within 2 days. I'll say within 2 days. I'll agree with that NOAA forecast, even though they didn't depict it on their Enlil spiral. And again, we'll have some South Pole-oriented coronal holes rotating in here. They're not so visible yet because the corona is very bumpy, which brings us to sunspots. So check it out, the sunspot number here moving back up above 150 in the past 24. And it's going to, let's see, it'll be at like 170 at least in the next 24 hours because we've got 3 new sunspot groups. So that'll raise it at least by 18. Every sunspot umbra counts as 6, and the sunspot counting, I won't get into the counting process. It's pretty convoluted. But we'll have at least 170 for the sunspot number in the coming day or two. There's the data from Royal Observatory of Belgium. And here is our flare probability monitor and so on. So we do have a significant possibility of large solar flares in various locations now because we've got a new sunspot right up here. There's this new group here, this new group here. 3451 has already produced significant flaring, so expect the likelihood of flares to remain very high. That's just the way it works, and let's take a look at some sunspots here from some more SDO imagery. Alrighty, so there is 1700 angstroms. And we'll switch to the grayscale HMI imagery here. So again, multiple new sunspot groups here. This one spontaneously and rapidly formed. Right there. One rose down here, and another one rose up here. Oh, and another one formed up here also. So that'll be at least 4 new sunspot groups. Will be probably over 180 sunspots in the coming 36 hours. And here's the 171 angstroms plus the colorized magnetogram. Just spectacular imagery there, combining the SDO AIA instrument and the HMI instrument. Just fantastic. Continuing on, it's time to move to things like solar flares and coronal mass ejections and solar energetic particles. So the GOES proton flux, let's show that, is still flatlined. Don't expect that to continue forever because, again, we have a high likelihood of large solar flares. The largest solar flare of the past 24 hours was an M2.5. There is that M2.5. Peak flux was around 1:30 universal time this morning. And let's move to some more SDO AIA imagery here. This is 94 angstroms yesterday plus today to date. So quite a bit of activity there in the northeast especially. Again, multiple locations have the capability of producing large solar flares. As we watch another major solar uptick in progress. And oh, I almost forgot. Let me just go back to one more thing here, because some people seem to think that we're at solar maximum already. So let me just reinforce these facts before we continue on. Once again, clearly not at solar maximum. So look at the past month here. This is a prime example of an ongoing uptick. We've got higher lows and higher highs. Expect those to continue. That is called a major upward trend, folks. Sun not shutting down and not at solar maximum. We're still probably over a year away from solar maximum. So, I mean, if that looks like a star that's shutting down to you, I think your brain has been shut down by watching too much crap. Yeah, crap. A lot of forecasts have been coming out in the previous, I don't know, couple of years that are not backed up by anything except hand-waving and complete and utter nonsense. Anyway, let's move on to take a look at a star chart. I guess that counts as space weather, right? So this is what's going on overhead at Lehigh Valley, Pennsylvania right now. The moon is setting, and Jupiter is right behind it. Venus is quite high in the sky, followed by Mercury, the Sun, and Mars. So if you're viewing the morning sky, you'd get a great view of the moon, Jupiter, Venus, and Mercury, perhaps. If you're viewing the early evening sky, you might get a great view of Mars right on the opposite side of the ecliptic from Spica there. So that's our star chart from skyandtelescope.org. Go ahead, create your own if you like. I like this one because it allows you to get a great view of what the horizon would look like by moving this little green bar around. Totally sweet. And there's the brightest star, Sirius. And here's your solar system forecast. I guess where planetary bodies are count as space weather. I mean, not really. Space weather is really just what's happening right here from sun to earth. But we won't get into things like the barycenter of the solar system and so on this video, since this is the daily space weather show. Here's your solar system forecast. There's where things are today. Here's where things will be in a week. We will have a crescent waning moon by the 8th of October. Today's astronomy photo of the day, pretty sweet, is an annular eclipse over the desert. So there you go, apod.nasa.gov if you want to go check that out yourself. Great image there of a single tree, some sand dunes, and that annular eclipse. Courtesy of Maxime Davidon. Continuing along to our coronal mass ejection imagery. We did have 2 significant CMEs in the past 24 hours. We do not anticipate either of those to be earthly directed. However, we'll show you the data anyway. If you think we messed up, leave us a comment and let us know that you think it is earthly directed. So there's one out of the east. That one came from behind the solar limb. And here you'll see one kind of out of the south. Oh, that must be today. There's one out of the west southwest. So that second one is also on the opposite side of the sun. Neither of those coronal mass ejections appear to be earthly directed based on the coronagraph imagery that we have available. Well, it looks like we have today now. Nope, no imagery from today from George Mason University, no problem. Here we've got, let's just switch to our more zoomed in views. Soho Lascaux C2 on the left in red, C3 on the right in blue. Let's get those a little bit more close to being synced up here. There we go. Please pay attention to the time and date stamps. Soho Lascaux C3 had a bunch of missing data in the previous couple of days, so we're still showing old data on the right. And there's another coronal mass ejection from this morning. Looks like it is out of the east as well. Anyway, here yesterday's events, there's that one out of the northeast. And then later, shortly right afterwards, basically, there's one out of the southwest. And let's show why we think these are not earthly directed. So we'll also show stereo A here. Feel free to pause the video on this frame if you're not familiar with the locations of things like Bepi Colombo and the Parker Solar Probe and the Solar Orbiter. Stereo A is depicted by that little red circle there. Still very close to the Earth, but moving a little farther away. And we've paused this at 2153 for the raw coronagraph and 2138 for the difference imagery. So there's that one out of the southwest. And we got the tail end of that one from the northeast. So let's show our custom coronagraphs now. And unfortunately, we don't have any SDO imagery because the Helio viewer was not up to date with the SDO imagery. So there are those 2 CMEs. One was around 1500 Universal Time and the other one was around 1800 Universal Time. Both yesterday, later in the day. There's a little closer view of those 2 coronal mass ejections. And let's take a look at 193 angstroms. So we're going to actually rock this back so we can show you that there were no plasma motions on the Earth side of the solar disk here. Normally we would have that all tied together using the Helio viewer video, but no can do this time. So here is the first CME. We don't really see any plasma motions. It did come out of the northeast. We don't really see anything moving around on the Earth side there. And then the other one, you will see a little flash here. Right there, you can sort of see a flash all around. An indication that that was an event from the far side. So there you go. There is your coronal mass ejection analysis. Sorry, aurora chasers, but you'll have to rely on coronal holes for your upcoming solar upticks. Fingers crossed for those. So continuing on here, we want to look at filaments next because the filament situation is pretty berserk. Check that out. Look at all those dark features, folks. Major number of plasma filaments here. And we've only got I think only one has a name at this point. It's this one right here. I named that one the Pierre-Marie Robitaille filament because today ought to be a national holiday, Cosmology Day. Yeah, celebrating the 10-year anniversary of Robitaille's paper 40 lines of evidence for condensed matter, the sun on trial, liquid metallic hydrogen as a solar building block. It's pretty serious. It might break your brain. Sorry, folks. Stars aren't electric. The universe isn't electric. Everything's not connected. Let me explain why everything's not connected. People say everything's connected because quantum mechanics, right? Well, guess what? Are you connected to a thing you can't measure? Ask your favorite quantum mechanic that. Are you connected to a thing that you can't measure? Anyway, look at all those filaments. That is a berserk number of filaments. We'll also show the grayscale imagery here. These are both of these are from El Teide, Spain. This one's zoomed out in order to show prominences, and you can see quite a few prominences here around the limb. Those are the same feature. They're just filaments that are overlapping the edge of the solar disk from Earth's perspective. And I think I say it daily, but if you want to name filaments, do it over on Twitter. Yeah, do it over on Twitter. Just follow the hashtag #NameThatFilament, and you too can name filaments after your friends, your foes, or perhaps even yourself. Lots of filaments to name, and I think there's only one that has a name. The Russell brand, I'm not sure if the Russell brand is still there. I don't know. Let me know. Hit me up on Twitter and tell me all about naming filaments. Anyway, this brings us almost to bonus features. Here are the past couple of hours, and there is some actual activity happening right now. There's a CME coming off right up here. You can see a filament. There's a little bit of limb darkening right there. So that is a coronal mass ejection, likely on its way out. It doesn't look like it's going to be earthly directed because I think it originated from down here. So it looks like it is moving in this direction. We're expecting to see that eject up on a trajectory that will miss Earth to the northeast. So that's the preliminary analysis of that. It is too early to see it on the coronagraphs, I would suspect. Again, that's the last couple of hours there, about 2.5 hours from the GOES 16 SUVI. And now it's time. Time for bonus features, which may have you deciding that you're going to get into a bunker for some reason, probably because you don't understand the science. Oh, look. Oh, my God. Also not scary. Satellite charging hazards. So that's when low-energy electrons build up on the outside of spacecraft. And there are some minor ones there moving into the Central Pacific Ocean right now. They're currently in the Eastern Pacific. And guess what? Those aren't going to kill you either. The GOES electron flux, also not going to kill you. It didn't reach the warning levels that NOAA forecasted. But there are the past 3 days of radiographic measurements by the GOES 16 and GOES 18. And I suspect we'll get back into warning levels once again today. Maybe we'll get those really high levels that NOAA forecasted for today or for yesterday. I don't know. Anyway, here's the 1 year graph. There's the 1 year graph of the relativistic electrons. Those are measured at the F layer of the ionosphere. And here is the forecast model. NOAA is expecting flat levels. The green box is the forecast. So we would expect to see a precipitous dip in the coming 2 days if indeed we do see a coronal hole high-speed stream impact. Next we'll show the layer of the atmosphere where that's measured. Yeah, the layer where it's measured, the F layer of the ionosphere. Feel free to pause the video on this frame. The F layer is at about 300 kilometers of altitude. And there it is in its vibrational frequency. Shout out to Kimberly Nichols, who creates paintings that weigh 18 pounds and uses approximately 4 gallons of paint per painting. Thanks, Kimberly, for recommending this. I think she did it by accident. She was like, hey, what's going on with the ionosphere over here? And I was like, what? The Australian Government Bureau of Meteorology has a sweet ionosphere map. Awesome. And then we started picking it up. This was probably about 4 years ago. But anyway, here's the anomalygram depicting anomaly in megahertz from a 30-day median. And the ionosphere is looking totally normal. Oh my God, the ionosphere! It's predicting Armageddon, folks! The apocalypse is coming via the ionosphere. No! The bridge between Earth and space has me spooked. Oh no, ionosphere, no! Get in your bunkers. Pardon my sarcasm. There's the latest image from 12:45 Universal Time. And there's the anomalygram. We also like to show the ionosphere nowcast. It's pretty sweet. It shows the total electron content anomaly, and the maximum usable frequency for radio communications. So if we have any ham radio users, there you go. There's a great map for you, the ionosphere nowcast. We recently picked it up because sometimes I notice stuff that I think we ought to cover. So there it is. And we'll close out our space weather section of this video with more electron content. So first we're going to show the total electron content, which is free electrons to about 12,500 miles of altitude. And oh no, the electron content is Nibiru. Nibiru is showing up on the electron content, folks. Pardon my sarcasm, once again. Total electron content is fairly organized here. Most of those free electrons from ground level to 12,500 miles are about where you'd expect them to be. We also like to show the electron content anomaly from the 10-day average over North America. Why? Because you never know when you'll get information that you weren't expecting. You know, science is very interesting because a lot of times in science, usually in science what happens, folks, is we all ask the same questions because generally people have the same understanding of things. So, most scientists are asking the same questions. And what happens is we don't end up with answers. We end up with instead more questions if we're doing things correctly. However, sometimes, often through immersion in the data sets, we find ourselves with answers to questions not asked. So some of the greatest advancements of all time in science were a result of obtaining answers to questions not asked. And that's how I came up with my crap theory that explains a plausible mechanism underlying the solar sunspot cycles. If you want to read about that, become a gold member at the Smash Team. There's no other way to know about it because it's not publicly visible unless you pay us some cash for it. Anyway, that's the total electron content anomaly average, from the 10-day average, rather. And we are seeing significant electron content anomalies here over North America. So we could be seeing some ground-based signals there. Check it out, from the Rockies to the west, significant total electron content signals of high electron contents, anomalies from the 10-day average. Ooh, there's one over Yellowstone. Oh no, it's because a supervolcano is going to erupt, folks. Just kidding, folks. It's extremely, extremely, extremely unlikely. We've also got some high electron content anomalies over Mexico and Central America. We'll play that through one more time, and then we'll show the latest images of the closest star to show you all those sweet new sunspots. Yeah, at least 4 new sunspot groups forming since yesterday. So there you go. There's the latest intensitygram. And here's the latest colorized magnetogram. We show that refresh just so you know you're seeing the latest imagery. So let's get a great image of all of these groups. Several sunspot groups up there. That one is growing rapidly. Here's another new one. Here's another new one. Here's another new one. And down there is another new one. So if you're frightened because you think the sun is shutting down, we should probably dispel those fears now. I know there are a lot of ridiculous YouTube channels that have no idea what they're talking about, that are telling you, oh, we don't want you to be scared. We just want you to buy bunker supplies from us. Anyway, we just want you to move to up in the mountains to an upland tundra to make you so safe because the oceans are going to slosh up and wash you away, folks. Oh, no. Oh, my God. Because the galaxy. Anyway, now that I got that out of my system, that's where we'll end the space weather section, and we'll move on to meteorology, a value-added service from the Smash News Network, least busted name in news. We're starting out with sea surface temperature anomalies and surface winds. So the color gradation is the sea surface temperature anomalies, and the animation is the surface wind scenario. And check it out. Here's this low that flooded the crap out of New York. A complete disaster caused by completely dated drainage systems. Bad water maintenance is what really was the cause of that. And of course, we forecasted those heavy rains. If you were watching the channel, you would have already known that they were coming before they arrived. So anyway, that's what's going on with surface winds and sea surface temperature anomalies. We've got some quite cool water here off the coast of New England. It is about 7.5 degrees below normal, and off the coast of New Jersey, we've got anomalously warm water. Actually, there's a lot of anomalously warm water in the North Atlantic. Another indication that the Gulf Stream, here are currents by the way, that the Gulf Stream isn't shutting down. Look at folks, it's still heating up Iceland and Ireland. There it is. You can see the currents. They're making it all the way up here. If you're banking on a year without a summer for Europe next year, you're also doing some bad banking. That banking is as bad as banking on a grand solar minimum. These things do not appear to be occurring, period. So here are the sea surface temperature anomalies for the Atlantic Ocean. As the southern hemisphere comes out of winter, it is now spring down there, if you weren't aware. There's the Arctic Ocean. A mix of anomalously warm and cool water. How about the Indian Ocean? We've got that covered. There you go. There are currents and sea surface temperature anomaly. Currents and sea surface temperature anomaly for the Southern Ocean. It's actually anomalously cold all around the Southern Ocean. How about that? Last but not least, the Pacific Ocean, the world's largest surface heat sink. Because water has a really high latency of heat, folks. It takes a lot of energy to heat water up, and it costs a lot of energy to cool water down. Anyway, here comes normal meteorology stuff. These are the air masses of planet Earth. Surface winds of the east are looking like this. Shout out to our viewers from this side of the planet. Here are the jet streams of the east. Shout out to our viewers from Oceania, the Far East, etc. If you're new to the channel, make sure you press subscribe, leave a comment, press the share button, as we have extremely low coverage. Shout out to our viewers from Africa, Europe, and the Middle East. If you're from this area, leave a comment, press share, press subscribe if you're new. Don't forget to press like, regardless of all of that stuff. Here are the surface winds of the central world. Surface winds of the west are looking like this. Oh my God, watch out for these controversial facts, folks. There's a low pressure system here south of Iceland, which, I don't know, that might spook somebody. So make sure you get in your bunker. Here are the jet streams, and there's that forecasted huge dip in the jet stream, which is bringing some snow to the northern Rockies. Anyway, next we're showing Saharan dust. Yeah, Saharan dust, because it is responsible for the lushness of the Caribbean. Did you know that Saharan dust has been fertilized in the Caribbean for an unknown length of time? Yeah. Anyway, there's quite a bit of it there. That's 84.7 micrograms per cubic meter in that area. It's about to get it's getting kind of dusty right now in the Caribbean, and it looks like it's on its way to Florida there. So a bunch of Saharan dust there making its way across the Atlantic Ocean. That data from windy.com. And that will not help to increase the strength of tropical type systems. Anyway, here are the clouds and fog for the Americas as we zoom in to the lower 48. That is the shortwave radiation map from the NASA GOES Interactive Weather Satellite Suite. Here is our weather.gov map, and we've got a bunch of fog warnings there and some gale warnings, I think, on the East Coast, the Northeast U.S. Also, I think some small craft advisories there around Florida. That is not... Okay. Anyway, there's the key, weather.gov, to get your weather warnings. Looks like some blizzard warnings there around Denali in Alaska. And here come some forecasts. So we're going to show the GFS 72-hour forecast for several different items here. This is the jet stream forecast, which is going to be continuing to bring cold air from well up in Canada all the way down to Mexico and beyond. That's your 72-hour jet stream forecast based on a GFS model. Here is our temperature anomaly forecast for the next 72 hours on the GFS model, as we're getting anomalously warm temperatures over the eastern portion of the U.S. and anomalously cold temperatures western Rockies and beyond. Next, this is your pressure and 10-meter winds. And that low pressure that brought all that rain to New York and New Jersey will be moving to the southeast in the coming 72 hours. It'll also be weakening a little bit there as it moves out off the coast there, eliminating its influence on East Coast weather. 72-hour GFS mean sea level pressure and wind forecast there. Next, your 72-hour GFS pressure and precipitation forecast. And the jet stream will be slowly making its way across the U.S. here, with that huge kink kind of breaking down in the coming days. And that's going to bring some heavy rains there. So here is the total accumulated precipitation forecast. That is total accumulated precipitation in inches based on a 72-hour GFS model. And here is the snowfall forecast. Some heavy snows here coming to Wyoming, Montana, Idaho, Nevada, California, Utah, Colorado. Some areas there looking like they're going to see over a foot of snow. Significant portions there with 6 inches or more. 72-hour GFS total accumulated snowfall forecast in inches is where we'll close out our custom forecasts from tropicaltidbits.com. Anyway, next, lightning. We had some lightning there across New Mexico, Utah. Well, you see the map. That's why we put the map up there, folks. We don't have that many blind viewers, but anyway, that's what's going on. Yeah, blind viewers. I guess they would be listeners. And next, lightningmaps.org to see a real-time lightning map. Next time you hear thunder, I highly recommend it. And the Middle East has some heavy lightning happening right now. The U.S., not so much. Northern Michigan's got some. Hey, Kalkaska, there's thunder rolling in. Worldwide, we've got about 162, I'll make it 300 plus strikes per minute right now. And by the way, once again, if you enjoy the content, don't just press like, hit the links below the video in the description. Help keep these videos existent, publicly visible, and free for all to view. Oh my God, my hand is breaking down. It must be because of the galaxy. It's energy from space. Oh no, I shouldn't have come out to space again. Oh, I'm so spooked. Oh, look at that. All that spooky stuff going on back there. It's the constellation Cygnus. Oh, there's nothing scarier than space, folks. SmashOmash.com is our homepage, and welcome to the Neo-Renaissance. Congratulations on realizing the channel exists. And again, you can find our links to social media. Press share, press like, etc. You haven't pressed like yet. Oh, geez. Do we have to... We were just about to finish the video, and now we got to wait for you to press like. So that's okay. We'll wait. No problem. You take your time. Take your good old time pressing the like button. If you're unable or unwilling to open your cobweb-encrusted wallet, become a bronze member at the Smash Team. SmashOmash.com/Smash Team. We'll close out with Doppler radar. Check it out. Some heavy precipitation here. And again, some snow fallen in the high mountains of Alaska. There is our Lower 48 Doppler. Here is the lower 48 clouds and fog. Lower 48 water vapor map, a great view of that low, which is entrained by a bunch of dry air here. And there's a mixture of warm and cold water there, so it does have the ability to create some convection. Anyway, here is the recap U.S. Doppler radar, our ground-based systems that depict vertical motion of things like water droplets and ice crystals. Here is infrared radiation from a space-based satellite system, part of the NASA GOES Interactive Weather Satellite Suite. The shortwave radiation map, it shows clouds and fog even at nighttime, and the water vapor map will clear things up if your Doppler is unclear. Another space-based system showing a different band of the infrared spectrum, showing all of the water vapor. And guess what? You can forecast your weather, whether it's space weather or Earth weather. Whether it's weather, you can forecast it. So you've got more than enough access. I mean, you can take physics from MIT. Like, there's plenty of information, folks. So the current state, I mean, right now what's really going on, what's interesting to me, is that the ratio of available information to actual information that people has is so insanely high that it's just berserk. You've got the internet, so you're viewing this video. You've got access to practically all of the information mankind has ever known throughout recorded history. There's no excuse to be clueless. Anyway, thanks for tuning into the Smash News Network, least busted name in news. I better go back to the bunker because I'm seeing all this space behind me and I am freaking spooked. So I'm going back to the bunker. In the meantime, may that solar wind be at your back. I'm going back to the bunker again. Whoa!